Good morning, students. Today's class is about Unit 5 Special Functions, the content, evaluation of definite integrals using beta and gamma functions. Beta function, just we recall them. Definition: if m and n are positive numbers, then beta function is defined by the integral 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx, and is denoted by beta of mn. Thus, beta of mn is integral of 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx. Properties of beta function: beta of mn is always equal to beta of nm. Property is known as symmetric. Other transformation of beta function is beta of mn is integral 0 to infinity y to the power of n minus 1 upon 1 plus y whole power m plus n dy. Beta of mn is integral 0 to 1 x power m minus 1 plus x power n minus 1 upon 1 plus x whole power m plus n dx. Beta of mn is 2 into integral of 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. Beta of mn is gamma of m into gamma of n upon gamma of m plus n. So it is the relation between beta and gamma function. Now definition of gamma function. If n is positive, then the gamma function is defined by the integral 0 to infinity e power minus x power n minus 1 dx, and is denoted by gamma of n. So defined as gamma of n is the improper integral, that is integral 0 to infinity e power minus x power n minus 1 dx. Properties of gamma function: gamma of n is always equal to n minus 1 gamma of n minus 1, replacing n by n plus 1. So we will have gamma of n plus 1 is n gamma of n, that is n factorial, which is used for positive integers, and gamma of n is gamma of n plus 1 by n. And we will have the definition, that is gamma of n by k power n is integral of 0 to infinity e power minus kx into x power n minus 1 dx, where k is constant. And we will have gamma of 1 is equal to 0 factorial, that is 1. Gamma 2 is 1 factorial 1. Gamma 3 is 2 factorial 2. Gamma 4 is 3 factorial 6. Gamma 100 is 99 factorial. So on continuing this process, we will have gamma of n plus 1 is n factorial. And we have gamma half is root pi. Gamma negative half is negative 2 root pi. Don't forget these values. So these are the properties of gamma function. And gamma 0, gamma minus 1, gamma minus 2, gamma minus 3, and so on are not defined. Gamma is not defined for negative integers, including 0. Gamma 0 is also not defined. No problem. Evaluate integral 0 to 1 x power 7 1 minus x whole power 5 dx by using beta and gamma functions. Solution: given integral of 0 to 1 x power 7 1 minus x whole power 5 dx, which is equal to integral 0 to 1, 7 can be written as 8 minus 1, 5 can be written as 6 minus 1. So we will have a beta function definition, that is integral 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx. So that here m is 8 and n is 6. So it is equal to beta of m comma n, that is 8 comma 6. But we have a relation between beta and gamma function, that is beta of mn is gamma of m into gamma of n by gamma of m plus n, that is gamma 8 into gamma 6 by gamma 8 plus 6. But gamma 8 is 7 factorial, gamma 6 is 5 factorial, gamma 14 is 13 factorial. On simplifying, we will get 1 by 10,296. So hence the required definite integral value, that is integral 0 to 1 x power 7 into 1 minus x whole power 5 dx is 1 by 10,296. So simply we can get the required definite integral value, that is improper definite integral value. So clearly the given integral is compared with integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx. By the definition of beta function, it is beta of mn, where m is 8 and n is 6. But we have a relation between beta and gamma function, that is beta of mn is equal to gamma of m into gamma of n by gamma of m plus n. Just simplifying, taking the gamma functional values, we will get the required constant. Another problem, evaluate integral 0 to infinity e 3 power minus 4x square dx. Solution, 3 power minus 4x square can be written as e to the power of minus 4x square log 3. Log 3 quotient is minus 4x square. That means log 3 power minus 4x square, because m log x is log x power m. So like that, e power log 3 power minus 4x square. E log get cancelled. We will have 3 power minus 4x square. So that 3 power minus 4x square can be written as e power minus 4x square log 3. So since 3 is e power log 3. Now integral 0 to infinity e 3 power minus 4x square dx is integral 0 to infinity e power minus 4x square log 3 dx. Here dx is missing, just write down. Now putting 2x into root of log 3 equal to some another variable y. Now differentiating on both sides, so that we will have dy by 2 into root of log 3. Now substituting these values and we will have same limits. So with these values, the integrand becomes in terms of y. So clearly here the constant is 1 by 2 root log 3 is constant. Just take it out the constant. Now on simplifying, so clearly this value already we have known, that is root pi by 2. That is root pi by 2 into 2 is 4 into log 3. So it is the required value, that is root of pi by 16 log 3. So it is the required value of the given integral. Show that integral of a to b x minus a whole power m b minus x whole power n dx is b minus a whole power m plus n plus 1 beta of m plus 1 comma n plus 1. Proof. For this we have to put x equal to a plus b minus a into y. Now differentiating on both sides, dx is a derivative is 0, b minus a constant, y derivative is dy. So thus we will have dx is b minus a into dy. Now limits, when x equal to a, that is lower limit, y value becomes 0. So substituting x equal to a here, clearly a get cancelled, b minus a is into y is 0, which implies that y is 0. When x equal to b, so substituting x equal to b, so we will have b minus a is equal to b minus a into y. Clearly b minus a get cancelled, so that y value is 1. These are the new limits, y equal to 0 and y equal to 1. So with these limits, the given integral becomes integral of a to b. But what is x here? A plus b minus a into y. So clearly a get cancelled. So we will have b minus a into y whole to the power of m. B minus x. But what is x here? A plus b minus a into y. Multiplying with minus, we will have minus a minus of b minus a into y. So b minus a minus of b minus a into y whole to the power of n. But what is a dx? Dx value is b minus a into dy. Now we will have b minus a into y whole power m is b minus a whole power m into y power m. Now taken out b minus a as common in second term, we will have b minus a whole power n into remaining term is 1 here, 1. In this remaining term is y, that is 1 minus y whole to the power of n into b minus a into dy. Now we can take out the constant as b minus a whole power m plus n plus 1 as common. So thus we will have b minus a whole power m plus n plus 1 integral of 0 to 1 y to the power of m into 1 minus y whole power n dy. So thus y power m can be written as y power m plus 1 minus 1, just adding 1 and subtracting 1. 1 minus 1 y whole power, just adding 1 and subtracting 1 into dy. So that is b minus a whole power m plus n plus 1. Now it is nothing but by the definition of main definition of beta function, that is beta of mn is integral 0 to 1 y to the power of m minus 1 1 minus y whole to the power of n minus 1 dy. But here m is replaced with m plus 1 and n is replaced with n plus 1. So the integral is nothing but beta of m plus 1 comma n plus 1. So thus the required statement is clearly proved. Hence proved. Another problem, prove that integral 0 to a minus x whole power m minus 1 x to the power of n minus 1 dx is a power m plus n minus 1 beta of mn. Proof, putting x equal to ay so that differentiating on both sides dx is a dy and limits when x equal to 0, that is lower limit, y value is 0 equal to ay, which implies that y is 0. When x equal to a, that is upper limit, a equal to ay, which implies that y is 1. So y equal to 0, y equal to 1 are the new limits. Old limits are 0, a. So with these values, the given integral on left hand side, it becomes integral of 0 to 1 a minus x, but what is x here? Ay. So a minus ay whole power m minus 1 x power n minus 1, but what is x? X value is ay whole power n minus 1, but what is a dx? Dx value is a dy. And what are the new limits? 0 to a, now it becomes 0 to 1, 0 to 1. Now simplifying by taking out the common as a, that is a power m minus 1 into a power n minus 1 into a, that is a power m plus n minus 1. So taking out the common as a power m plus n minus 1. Now substituting y equal to x, differentiating on both sides, we will have dy equal to dx and we will have same limits 0 to 1, because when y equal to 0, x equal to 0, and when y equal to 1, x equal to 1. So same limits are obtained. Thus the above integral becomes a power m plus n minus 1 is constant, integral 0 to 1, y is replaced with x, that is x power n minus 1, 1 minus y is replaced with x whole power m minus 1 dy. But what is the dy here? Dx. Now it is nothing but beta function definition. What is beta function definition? Beta of mn is integral of 0 to 1 x to the power of m minus 1 1 minus x whole power n minus 1 dx. But here m n are interchanged, so it is nothing but beta of nm. So beta of nm, but we know that beta function satisfies symmetric condition, that is beta of nm is always equal to beta of mn. Hence a power m plus n minus 1 is beta of mn, because beta of mn is nothing but beta of nm. So hence the required statement is clearly proved. So these are the problems related to evaluation of definite integrals using beta and gamma functions. For any queries, please contact. Thank you.